resume the recording. So welcome everyone. Just letting people file in now and we'll start our program in a minute or two. Okay. Maybe I should have brought some elevator music to play during the beginning here.
Good evening, everyone.
Hi. Thank you all for joining. So I just wanted to let everyone know we'll get started in about a minute, and thank you for coming. While we're waiting, did people who ordered their tea kits, did everyone's tea kit arrive?
All right.
Yes, Carmen's did. That's exciting. David's did.
David
And Deb's did.
Great.
Very true. I think Terry has the same cup that I have.
Oh, good.
Oh,
Oh, an Iowa
Oh.
cup.
wow.
Wow.
Excellent. Yeah.
All right, I'm glad they
anxiously
arrived.
awaiting mine.
I know, it's a bummer they haven't shown up to California yet, I think. Taking a little bit longer. All right. So I'll go ahead and start our presentation today. And
Samantha, did you want us to go through introductions first, or you want us to wait until after your intro?
please go ahead and start. It's just going to take me a moment to pull this up.
Okay, perfect time actually to do that. So I think the size of this Zoom room is manageable enough that we can go around and introduce ourselves. You heard a lot from me yesterday. I'm Mahta Moghadam. I'm the lead PI of the SoilTech Center. I'm at the University of Southern California, where I've been for about 9 years. I used to be at the University of Michigan before that, also on the Faculty of Electrical Engineering. And prior to that, I was at NASA JPL for several years as well. And that's where I got into remote sensing and radar systems for environmental applications, and quite focused on soil as well. A lot of soil moisture work and soil composition as well. So yeah, so that's who I am. Let's and I know everyone's Zoom listing is different. So maybe I'll just go based on the list I have in front of me. So Payman, you're next on my list.
So my name is Payman Arabshahi. I'm at the University of Washington, also Department of Electrical and Computer Engineering. I've been at the UW since about 2006. Before that, I was at NASA JPL also for about a decade. Before that, I was at another school, and before that, I was mostly goofing off as a grad student. Background, PhD dissertation was in machine learning AI. Once I joined JPL, it rapidly turned into networks and communications, space communications. And then that has stayed essentially. So the background is in wireless networks, wireless communications, underwater, space, satellite networking, and the like. And with Mahta and Carmen and Baikun, we're trying to spin up this center now on essentially environmental monitoring focused on soil.
Great, thanks, Payman. Audrey?
Forgot to unmute myself. Sorry, we're having slow internet today. My name is Dr. Audrey Reiner. I'm a postdoctoral researcher at the Data Institute for Societal Challenges located in Norman, Oklahoma. My research interests largely lie at developing visual analytics systems for large-scale climate, food, and water applications. So can you look at, just within the vein of some of the projects that were talked about yesterday, how do you turn this information that we're collecting from soil, that's all this data, and turn it into something that we need to make it actionable to a human. So how do we focus on taking this data that we have and turning it into something that we can use?
Great, thank you.
I'm
David.
just going to break in very quick to display another slide that asks if you're willing to please let us know who you are by renaming yourself in the Zoom panel so we can get a sense of who we're talking to.
Right.
So thank you, everyone.
Right. And the names, we can see the institutions sometimes aren't completely obvious. But
yeah.
Great, thank you, Audrey. David Ertel.
I'm David Ertel. I work for Iowa Corn, which is a joint organization made up of the Iowa Corn Growers Association and the Iowa Corn Promotion Board. And our role is to support farmers. We're funded by farmers, and we conduct marketing, education, research, and advocacy policy type work here. So a lot of different things related to supporting farming. I'm in the research group here, and this is of interest for a couple of reasons. One, we're very interested in plant phenotyping. I've been very closely involved with several researchers up at Iowa State, and I'm on the executive board of the Genomes to Field initiative, which is a nationwide corn phenotyping experiment. And more recently, part of the NIFA Ag Genome to Phenome project, which is also run out of Iowa State as well as several other universities. So we're always interested in understanding new ways of observing and measuring plants. And the second area of interest is that of environmental issues. We're also very interested in understanding how to reduce pollution, reduce runoff, leaching, and that obviously centers around soil health. So soil health is a very big issue, and obviously being able to measure characteristics of soil is going to become increasingly important, especially as we get into start trading carbon market credits and being able to validate those. It's, we're not going to be able to validate in the field for most of these fields. So we're going to need ways of seeing into the soil and seeing how much organic matter is there.
And we are quite excited actually to discuss that with you. We might have
and I should mention, I'm a graduate of both the University of Connecticut and Iowa State University. So
oh, goodness.
2 of the 5 organizations.
Excellent. Well, thank you, David. Welcome. Carmen, speaking of Iowa State.
So my name is Carmen Gomez. I'm an associate professor here at Mechanical Engineering Department. My background is in agriculture and biological engineering. So I got my degree at Texas A&M, my PhD there. And then I became a faculty and got tenure at Texas A&M in the agriculture and biological engineering department there. And my work has always been related to agriculture and food applications. Most of my initial work was related to food processing. And then I slowly started migrating towards pre-harvest and also sensors. So I've been working here at Iowa State since 2017. And with that, I have expanded my collaborations in the mechanical engineering department, and this opportunity for making the center became a reality. And I'm excited to be collaborating with Mata, Payman, Bacon. This opportunity has really expanded our ability to collaborate across the United States. So it's great. And like David was mentioning, Iowa is very strong in agriculture. So we can see this center making a major impact. Good, glad to be here.
Great. Thank you, Carmen. And another Iowa State colleague, Jonathan, would you like to go next?
Yeah, absolutely. So I'm also a professor of mechanical engineering at Iowa State University with Carmen, and we've been working closely trying to get this center together here for Iowa State. So my research background is in biosensors, and we've worked a number of years in making nutrient sensor probes to go in soil to measure fertilizer ions. We also have a number of grants working on measuring pesticides and water quality in watersheds. So we've been doing that here in Iowa, and we're excited to kind of team up with this center and expand our research and interface with industry.
Great. Thank you. Jim Towie.
Hi, well, great to be here, folks. So my name is Jim Towie. My background is I have a bachelor's and master's in electrical engineering, and I've probably been in product development for about 30 years in a variety of industries, from United Technologies and doing avionics control to mobile applications for mobile. Currently, I'm running a company called Onset Computer. You guys may know of us. We produce the Hobo data loggers. It's a 40-year-old company, and we produce battery-powered value data capture systems, and we're quite interested in the whole research to commercial continuum. We're about an hour south of Boston. We're down near Woods Hole Institute. Origins in really deep ocean research, and we've kind of pivoted over the years into a variety of different areas. Like David, actually, I'm a UConn grad and a proud father of an Iowa State grad, so it's a funny tie-in there, but. We've also participated in Iowa with the Iowa Agritech Accelerator, looking at a variety of technologies that might be ready for commercialization. And so.
Wonderful. Thank you. And sorry about the pronunciation.
Oh, no worries. That's much worse.
Got that. Great. Welcome, Jim. Deb.
Hey, my name is Deb Sahu. I'm a faculty at Clemson University. I joined last year and COVID hit, so still working from home, occasionally going to my lab. Prior to that, I was in industry for about 12 years. My research interests are pretty much in applications of, I don't develop sensors, but I look for sensors. How do I apply sensors to monitor nutrients, contaminants, particularly nitrogen and phosphorus, and my interest into algal systems, how that affect algal blooms. So I applied some of the commercially available sensors to monitor phosphorus, nitrogen, chlorophyll. So my interests are into understanding ecosystems and how do we monitor, particularly in real time. So
Great.
That's why I'm here.
Thank you.
And Deb, just saying, Martha, Deb was we used to be graduate students at Texas A&M at the same time. So
yeah, prior to that, thanks, Carmen, for bringing that up. Yeah, I'm a proud grad of Texas A&M. Yeah.
Excellent. For those who joined more recently, we're just going around the Zoom room, doing brief introductions so that everyone knows everybody else. And I'm just going based on the list I see on my screen. There's no other order really that I'm following. So Elizabeth, would you mind going next? Elizabeth Pierce.
Thank you. I have to say how flattered I am to have been included, and how amazed I am at all of your backgrounds and everything you've done. I actually come out of finance. I used to run a mutual fund. I got involved with, I worked at Northern Trust for 7 years and had a number of clients who owned vineyards, but and marketed to that region. So I was very aware of the importance of agriculture in California. But I met Dr. Ingham and thought that there was some merit to her approach to this, what I think of as the full portfolio of biology, all the different types of life. But in my mind, it was bench level science that really couldn't be scaled. And I've spent the last 3 years working on creating a way to basically scale I should say, her scale to meet her biological endpoints. And so we are now in the process of rolling out production hubs that will essentially farm indigenous soil microbes that have been locally captured and farmed to create products that allow biological farming to be more effective. So where you think of an ag biologic as having very specific microbes in very specific amounts, or at the other extreme, we're looking at thousands of species, all locally sourced, covering 7 different major types of life. And we're now in the process of beginning to talk to academics about let's start some field trials and capture some real data. Let's see if we can't move biologic farming from something that's sort of been a little woo-woo to something that's got more metrics behind it and is more applicable to mainstream farming.
That sounds great. Definitely looking forward to working with you to help you with
Thank
that
you.
if we can. Thanks, Elizabeth. John Wilson, my colleague at USC. Let's see if, John, we can't hear you. You're on mute.
I muted myself, sorry.
There we go.
I'm John Wilson. I'm a professor and founding director of the Spatial Sciences group at USC here. I also have faculty appointments in engineering and architecture and medicine. I think I'm the project lead for something here called the Urban Trees Initiative. So most of my work has been built around environmental issues in both agricultural as well as urban settings. My work today spans science, sort of engineering and design, and most of it makes use of spatial analysis, spatial modeling and mapping, and things like GIS and GPS and remote sensing and so forth then feature prominently in my work. I'm a New Zealander by birth, did my PhD in Canada. That PhD modeled landscape change in agricultural settings over a 130-year period from 1850 to 1980. Prior to coming to USC, I was at Montana State University, had faculty appointments in earth sciences and plant and soil science, and I had an appointment in the Ag Experiment Station there. My research team built the StatsGo soil geographic database for the state of Montana, and I believe my research group in plant soil science with soil science colleagues, we had the first GIS GPS precision agriculture demo running live in the United States way back in the early 1980s.
Thank you, John. So a lot of the geospatial analysis work that we are hoping to do through the center would be led by John because of all the huge experience he has in that area. So let's see, let's go to Lyle. Lyle, is it Pakskowski? Is that the right pronunciation of your last name?
Yeah, sure. Lyle Pakowski. I'm with T-Mobile. I'm in the Advanced and Emerging Technology group. I'm basically a technology development strategist. I have keen interest in sensor technologies, in addition to which my 2 sisters and I have a 2,000-acre grain farm in North Dakota. So this is real science to me in 2 different directions.
That's wonderful. Thanks, Lyle. Durga.
Yes, hi everyone. Glad to be in this discussion. Very nice to meet all of you with such a diverse background. I serve T-Mobile as a director in the same group that Lyle is in, Advanced and Emerging Technologies. I've been with Sprint for a couple of decades, working on 3G, 4G, and 5G, and then within just the last year, I've been part of T-Mobile. And I'm currently looking at use cases for 5G, especially in the millimeter wave, but of course the low band and mid band, they are critical as well. So we are looking at all of the spectrum assets we have and trying to figure out how we can meet the current demands. Prior to joining Sprint, I was with Carnegie Mellon. I did my doctorate there on unlicensed spectrum and resource allocation, sharing, and things like that. And before that, I had the privilege of working for Norman Abramson at University of Hawaii. This was back in the slotted Aloha days before Wi-Fi was a thing. But I'll stop there before you guys know how young I really am. But glad to meet all of you. Thank you.
Great. Thank you, Durga. Maria Mushammer.
Hi everyone, my name is Maria. I'm from Austria, so I graduated at the University of Vienna. I'm a soil biogeochemist and microbial ecologist. I moved then to the US, to California, and I was at UC Berkeley. And after this, I switched to industry, and I'm now a scientist at Trace Genomics. Trace Genomics is a soil testing company. Our core technology is the sequencing of soil DNA. We provide information to growers and agronomists to help them or give them another tool for making agronomic decisions. Our mission is really aligned with soil health, sustainability, and also carbon sequestration. So we're very interested in collaborations and merging of different techniques like direct measurements with really other technologies to scale up those measurements. So there I'm really excited about a few projects on the list. And overall, I find all of the projects are super interesting and about the various sensor technologies. So I'm really excited to hear about those projects.
Well, thank you. Fantastic. Looking forward to working with you. Great. Okay, and let's go to Karthi.
Hi, I go by Karthi. I'm Karthikeyan. I'm a professor at Clemson University. My training is agricultural and biological engineering with a focus in biochemical processes and water quality monitoring and modeling. And before Clemson, I was at Texas A&M. So Carmen, I know Carmen as a student and then as a colleague, and also Deb as a student and now as a colleague. So my experience and expertise is pretty much in water quality, pathogen monitoring and modeling.
Okay, great. Thank you. Let's go to Mike Bates.
Yeah, hello. My name is Mike Bates from Thermo Fisher Research and Development. My background is actually in electrochemical energy storage and transfer at Northeastern University. So I worked on fuel cells and batteries, but for the past 5 years, I've been working on water quality sensors, various chemical sensors, biochemical sensors, and the site of Thermo Fisher that I'm at now, of which, there's lots of sites all over the country, all over the world, but our site focuses on water quality analysis and water purification systems.
Great. Thank you, Mike. Let's go to Baikun and then Matt from UConn.
Yeah, hi everyone. This is Baikun Lee, and very glad to see all of you here. And I see several industry partners that we already contacted at Mike. Thank you so much for joining here. And yeah, and also Jim from outside. Yeah, so it's really nice to see all of you. And also I see Dave, right? Dave, you mentioned that you are also alumni from UConn. And I was say, okay, but this is really nice. Yeah, decide that we can say hello to each other. Yeah, and I'm the professor of environmental engineering, and I already been at UConn for I think 15 years. Yeah, my research is about the water and the soil sensor development, real-time in-situ monitoring of environmental systems, and also resource recovery from wastewater. And currently that we are doing the tremendous of the research about signal collection and also very the long-term durable environmental sensor development. Thank you.
Great. Thanks, Baikun. Yeah.
All right, thanks. My name is Matt Stuber. I'm an assistant professor at UConn. I've been there, I guess, about 5 years now. And I'm in the chemical and biomolecular engineering department. My background is in process systems engineering, which is really the convergence of, I guess, chemical engineering, computer science, and operations research. And I focus on optimizing systems, so modeling systems, but primarily bringing those models, kind of complicated models of these systems, to make optimal decisions. And I have a background in developing water purification technologies, specifically in the agricultural sector, where we were essentially desalinating agricultural drainage water for soil salination management. So I just have a kind of a personal interest in agriculture and in water and resource management. But again, from kind of the computational aspects to designing new technologies in that space.
Great, thank you, Matt. And I see that Yu has joined. Yu, please go ahead. Yulei from UConn.
Hi, everyone. So this is Yulei from the UConn Chemical and Biomolecular Engineering. So I'm in the same department as Matt. So I joined UConn in 2006. So before I joined UConn, so I spent almost 2 years in Singapore. And finally, so I decided to move back to US. So my whole research life basically focused on all type of sensor and biosensor. So when I studied in the UC Riverside, so for my PhD, so I work on pesticides-based detection. So they developed all type of biosensors, so for pesticides. So after I started my independent research career, so I focused on all type of sensors, so environmental sensor, including collaboration with Professor Bai Kun Li on the nitrogen species sensor, and so on. So recently I also work on the Raman-based sensor, so for environmental or for the soil contaminant, such as the pesticide, PCB, and even working on that emerging contaminant like PFAS. So hopefully, so through this IUCRC center, so we can find the industry partner to work to have a common interest in the development of various type of soil sensors. Thank you.
Thank you. And let's see, I want to give a shout out to Mia Zhao. She's my PhD student. Mia, did you want to introduce yourself? She's been helping us in the background with Zoom arrangements. Go ahead.
Yeah. Hi, everyone. My name is Yuhuan Zhao. So you can also call me Mia, PhD student at University of Southern California, supervised by Marta Magudem. And currently, I'm the second year PhD. So my research field is basically Boreal area focused on Alaska. Right now, I'm under the project of above, which is Arctic Boreal vulnerable.
I think we've lost Mia's audio feed here.
Yeah, maybe we can come back to
yeah,
Mia in just a second.
Yeah, okay. You're back now. Okay, we lost you for a second, Mia.
Oh, sorry. So I mean, that's pretty much my research field, and I mean, it's great pleasure to join the meeting and to see all the great work you have done, and I feel so, excited about all the things.
Great, thanks for the help you're providing, Mia. Yeah, so the part that we missed in what Mia was saying in her research is that she works on Arctic soils and high carbon soils and characterizing them using radar systems. And of course, Samantha, our she is making this whole thing happen. She's keeping us in line. So I'm gonna give the floor to you, Samantha. I know you have a couple of polls for our attendees, so go ahead and explain.
Yeah. And I just wanted to also add that I don't think Max has yet introduced himself.
Max said he's going to step away for a second. I don't know. Max, are you back?
May not be.
Yeah, I just sent the chat saying that he's going to step away for a few minutes, but we'll make sure to introduce him when he's back.
Sounds good.
Pardon?
And Terry.
Yeah.
Oh, is Terry here? Terry, did I not call on you? I'm sorry about that. Terry.
I must be pretty memorable. So I'm Terry Grant. I'm at the UW. I'm a chemical engineer by training. Go Bears. I studied separation science for my PhD. And I worked for Weyerhaeuser for 20 plus years and got to use hobo data loggers and other sensors that are in that case recording instruments that are deployed. And I worked both on agriculture from the point of view of forests, but also Weyerhaeuser at the time was the largest packaging manufacturer. So we did a lot of work in the Salinas Valley with packaging foods to ship across the country. And that's why I spent lots of time behind broccoli rigs and other things trying to get harvest to New York and other places in good shape.
Thanks, Terry. And I'm also realizing I missed one other person, Audrey.
I think Audrey did go at the beginning.
Did she go at the beginning? And I've...
Yeah.
Okay.
Yeah.
Okay. So, and I don't see her now, so maybe that's why it was in and out of... Okay, well, good. I'm glad at least I didn't miss her. So back to you, Samantha.
Thanks. So my name is Samantha Danner, and I work for the Viterbi School of Engineering at the University of Southern California as a project manager. So I'm helping right now with various proposals, including the Center for Soil Dynamics Technologies proposal. And I have no research background in this area, but I did get a PhD in linguistics from University of Southern California, and also went and did my undergrad in Texas, not at Texas A&M, but at U Austin. So there's a rivalry.
Oh yeah, don't don't say that too loud.
And we're very pleased and thank everyone for joining us today.
Thanks, Samantha. Did you want to run the poll, the first poll?
Yeah, and I did see, it looks like Max came back, so maybe he'd like to briefly introduce himself because he has an important role to play here as well.
Absolutely.
Thanks, Samantha. Yeah, hey guys, so my name is Max Green. I'm a mechanical engineer by training. I'm actually here in a completely different role. So I am an assessment coordinator for the National Science Foundation. I'm here to support Prakash and the center leadership, Mata and her team, to really get this thing kicked off and get the center stood up. So I'm looking forward to working with all of you and hearing your feedback about kind of where the center is headed and how the center can best meet your needs. So glad to be here. I'm sorry I had to step away. I had to go make my tea. I went and made my tea for a moment. So
great. Glad you have your tea kit.
Okay, so yeah, we're very glad that it looks like a lot of people have received their tea kits. You may be getting one a little bit later. I know that Californians have probably not received theirs yet, but we will make sure to follow up with you if you ordered a tea kit to make sure that you get one. So I just wanted to briefly start one of the polls that we have for today. Just to understand more about the areas of interest among the people who have joined us today. So I'm going to go ahead and get some results from you all, and we'll just leave this open for a few minutes. But if you can give us an idea of which of our research areas is most interesting to you or your company, we'd be very pleased to know more about that.
Samantha, is it only for the companies or is it also for the research or universities?
Is it, the question is whether you're asking for the areas of interest for the companies?
Yeah, is it only the company people to answer or is it for everybody?
Oh, everyone can answer. It's not limited to only companies, but yeah, any of the research areas that are of interest to you.
Thank you.
Yep. And maybe if Mato wants to explain a little bit about some of the research areas that we're most excited about, I think that would be helpful to give
So
an idea.
did you want to leave the poll running, Samantha, while we...
Yeah, I'll leave it up for just a few more
Okay,
minutes so people
got it.
can get their answers in.
Okay, all right, got it. Yes, so we really would like to understand where your interests and priorities are on the company side. You saw sampling of some of the projects that we are working on or are proposing to work on. Of course, pretty much all of those projects that you saw were based on work that we have done. So uh, there's strong background in all of those areas among the different partners, but we obviously want to propose new things which are aligned with your interests. So really, we would like to make this time available to you to tell us which ones of the projects you saw were of most interest. And of course, we understand there's among different companies, there's different interests. So please do speak up. Let us know which areas were of more interest, and if the topic was of interest, but the solutions we're proposing were not in line with what you think is reasonable or practical, we would like to hear about that too. So consider this a chance for you to give us feedback, the initial chance to give feedback. Of course, tomorrow we'll have more official, like, formal opportunity to hear your feedback. But this is, again, consider this informal, just a friendly forum for letting us know what's up.
Also, I think if you have just general questions about this whole IUCRC Center program at NSF, what is it all about? Are there concerns that you have on research, hiring, joint projects, IP? Please feel free.
David, looks like you unmuted.
Yeah, in that poll, we could only select one, but I just want to let you know there are several that I could have checked if I could check multiples. So.
Thank you. That's a great point. Yeah, if you have a second area of interest or even more than two, please feel free to leave that in the chat.
Yeah, I mean, sort of playing off what David said, I mean, I think there's multiple threads to the ultimate solution, right? And the ultimate solution in commercialization is going to be multiple different companies. So I think, to be honest with you, the center's value from our perspective is that you do have tangentially all related pieces of the puzzle, right? And what is the puzzle? It's sort of, I think your name is quite appropriate, the Center for Soil Dynamics, right? And that applies across a massive spectrum of applications. And, from our perspective, I mean, there's the sensors, clearly. I think that's, the in situ sensors, but I also think the fusion of what's going on geospatially or from satellites or UAVs to sort of allow guidance and proof of concepts for, you can't do in situ everywhere. And, spatially, you can't get the resolution you need. So there's a hybrid system where you're fusing this data together. And all those pieces of the puzzle you guys are touching on. So, I mean, so I agree with David. I think there's multiple areas that are all related. Specifically for our company, I think the sensors are probably the biggest, applicable thing now. But I think for the problem that has to be solved, it's all of the elements you guys are touching on.
Great, that's really good to know. So for your company, and you mentioned you're most interested in sensors. Do you have, let's say, for lack of a better term, like a branch or a section somewhere within your company that you do already do geospatial analysis or larger scale analysis?
No, it's not something that our company is really focused on. I think there's companies out there that might take our instrumentation and make in situ measurements to then validate geospatial type of applications. But we're mostly an in situ sensor measurement company. I just think to solve the real problem, you need the hybrid and the fusion of both, even to influence and guide where should you place in situ measurements and of what type to get meaningful decision making. So.
Right. So, and please, everybody else in here. So speaking, deciding where to put sensors, how much of that do you already do? So you develop sensors, you also deploy them? So you the end users with the deployments as well?
I'm sorry, Meta, were you asking Jim?
Yeah, I was, yes.
Yeah. So we typically integrate sensors, and then we sell to integrators who are deploying to end customers is the typical thing, or we sell directly to researchers, or I call them technocrats. They may be paid consultants via state grants or funding that are needing to make measurements.
See.
So I might comment that I'm not a developer of technology, I'm a user of it. You know, we run research programs that use various sensors. And I've noticed these go through an evolution. First, it's finding and learning how to use a sensor. Then it's how to deal with the data, which is an ongoing process, especially some of these images create huge data files that plant scientists aren't used to dealing with that kind of data. And just, you know, transferring it, storing it, retrieving it is a huge issue. And then there's, you know, we're not even at the point of analyzing it yet, but that's our ultimate goal. But I think a lot of people would recognize that you go through these phases of learning curves, and sometimes the technology of the sensor itself is fairly straightforward, but it's the application use of it and then making sense of all that data that's the real challenge.
Great.
David,
when I'm looking down, sorry, I'm looking down, I'm trying to take notes, so that's why I'm looking away every now and then. Go ahead, I'm sorry.
David, of course, you actually need the synoptic view as well as the in situ measurements to make sense of the information well enough to make operational decisions. And that, of course, might vary depending on whether we're talking about maybe irrigated agriculture or rain-fed agriculture, or even, you know, pasture and grassland and things like that. So there's a lot of important issues and a lot of emerging issues around that in terms of, you know, what you've already some people have spoken about, like carbon sequestration and credits and trading and so forth. So I can see that this information is going to become, and the ability to both collect it, analyze it, and integrate it quickly is going to become, you know, in the next sort of 10, 15 years, one of the most sought after outcomes in this domain.
Yeah, for some applications, it's a quick in the field decision. But I should have clarified, I'm really looking at research projects where we're trying to take these tools and learn about plant growth and development.
Yeah.
But I think farmers are going to have the same needs.
Yeah.
You know, for example, with remote sensing, a lot of farmers are doing it, but they don't really know what they're doing it for yet.
Yeah, I definitely agree with that, because I mean, I've been in the remote sensing business for close to 30 years now. And I think we have had this communication block, or maybe it's more than a communication block. It's basically transitioning a lot of fancy products into the hands of people who can really use them, like farmers. These large data sets, image formats that are not really intuitive to use, all these different, you know, you tell people, okay, it's NetCDF or it's HDF5. Most people really don't know what that is, what those are, for good reason. I mean, they really shouldn't. They don't need to know. And maybe something that, you know, we can collectively think about is how we can make some of the existing products more accessible. It's not trivial, actually. It's a lot of research that can go in there, not just from the technical perspective, but also communication perspective. But for you who do deal with the end users, I think that's something that we could definitely use the help.
And I think from a farmer's perspective, they just want a tool that gives them something to make a decision on, or maybe even makes the decision for them. They don't want to mess with the data. They don't want to know how it works. They don't, you know, they would just prefer to put it out there and let it do its thing, you know, have somebody else manage the data, run the application, and send them the output. You know, it's got to be simple for the end user.
So is that thing that might might be a topic for the center to focus on. Again, it's not trivial. There's definitely research involved with that. It's not just writing code and making it available to everybody. There is
yes, I definitely agree. For us that develop the sensors, we are always thinking about how to integrate the data, how to communicate this in a way that people can interpret and make decisions, like David was saying. And one of the things that I think we would benefit from the center is this type of data integration that different platforms can communicate across. And farmers or whoever is using the sensors, they don't need to be changing platforms to be able to get the information they need. But yes, I think when it comes to networking and the sensors, data integration, data analytics, I think that's one of the things that the convergence of this center would be very beneficial. So as a researcher, I see that.
Yeah, and also I think that's I really enjoy this type of discussion because it's really expand our vision. Normally, let's say that at UConn, that's Yule and I developed this soil sensor node. Okay, and actually we already got this on-site at Jim, CEO there. Yeah, and Jim provide I mean a lot of the input, such as how can you develop the sensor hardware. Not just sensor node. We focus on how can our sensor material last longer in the wastewater or in the soil. But normally for a lot of industry, you'll say, what interface between your sensor node with this data collection, data correction, the algorithm, this type of interface. And also if you go further, what the sensor network. So that will be another, the further. And so I think that's we can, I mean, for center-wise, we can definitely think about for sensor node development, that's the one of our strengths. I'm sure Carmen and Jonathan also, expert on that part. But I think another direction will be what's the connection between the sensor node and the hardware. There's definitely a lot of the gap there. I'm sure industry partners such as Jim, I'm sure that you also interested in that part. Because this will be the whole sensor prototype, the whole kit.
Right. Elizabeth, you had a comment in the chat box about the economics of all of this, of company perspective. I mean that should be the baseline assumption. But did you want to elaborate on that in terms of what's guiding the technical work and the research? You see, did we lose Elizabeth? I don't see her on. Maybe we lost her. But there's a comment in the chat box, economic benefit, of course, again, I think it's definitely a given. And we would depend on you, our industry partners, to tell us what is it that to have that economic benefit. And David also, let's see, actually, Mike, you had a comment here with respect to farmer-friendly tech. Did you want to speak to that?
Yeah, I guess I can just briefly say it sounds very much like what I've heard from a former colleague of mine, where, there are companies like the companies working for Indigo Ag that are figuring out, how to harness data, big data, to help farmers, and they kind of are presenting a service model. So they, collect all the data, analyze it for them, and help the farmers then, decide when and where and how to plant and even how to sell their goods. I know that one of the big features was just, helping them make a profit by thinking of new markets and, interesting strategies like that. Also, so just to put in 2 cents on the sensor aspect of it, not the systems level or the, user friendliness, but one of the things that really interests me on the sensors level is some of the things that Elizabeth and Kathy had talked about. And, in particular, the idea of like microbe enhanced farming or pathogen monitoring. There's been availability of some of the chemical soil sensors for decades now, but it'll be really interesting to see what innovations come out of automated or remote biosensing, and how can we take the microbiome and enhance plants and monitor for invasive pathogens. So that's really interesting, I think, in this field, the technology of this field.
Great. It's very helpful feedback there. Thank you. And David, interesting comment. Yes, people don't want to have 20 different things going on, right? So please feel free to elaborate on that. Integration of applications, I guess that's.
Yeah, well, we see a lot of, this is really ripe territory for startup companies. They're all developing their own little tool or sensor or application. But farmers aren't going to be interested in just going out and having to purchase multiple.
Mm-hmm. Oh, this is not David's. Okay.
I should probably mention too, a lot of these probably wouldn't be targeted at the farmer themselves, but more likely at a crop consultant or an agronomist or a co-op who could then provide the service to their customers.
Hmm. So can you enlighten us, or at least me, on that? How does that work? So if we wanted to go and pitch this wonderful idea, whatever it might be, or a combination of ideas to a grower, what's the point of entry there?
Yeah, that's tough because, there's 70,000 farmers in Iowa. Where are you going to start?
Yeah.
So you're going to probably start with providers of inputs or services. And in the Midwest, it's the co-op that sells the seed and the fertilizer and buys the grain. They're also the ones that provide a lot of the agronomic consulting. So that would be the likely entry point for introducing something like this.
Interesting.
But it depends. If you're talking about a soil sensor that can measure soil carbon, that would be a different approach that you'd probably go through one of these carbon market organizations, perhaps. That might be a different audience.
Great. Thanks. And Jim, you have a comment. Did you want to speak to that?
No, I think it's just really echoing what's been said before. Maybe it would be useful. So, we as an organization spent several years as members of the Iowa Agritech Accelerator. To David's point, there are plenty. There are hundreds of startups trying to figure out certain specification and niches, and what each one of them found is it is very difficult to figure out how to approach this very broad market set, right? And I agree. I think what folks probably saw the biggest success that we're doing it, we're approaching the co-ops or the extension offices to kind of get access to those customers. But in the end, the end customer or the grower just really wants all this data boiled down into either a decision recommendation that they can act on. They don't want to goof around with worrying about what file formats or capturing data or running it through some algorithm to they want to take action on it. So but that's why I think the center actually is I'm really jazzed about all the different aspects of how you guys are focusing on things. And then coming back to the first question is there isn't a specific area for this center to be successful. It cannot choose one of those. It has to choose the right mix of all 3 or 4 of those areas that you're looking at to ultimately be successful. And as an industry organization, sure, we have a commercial interest in a very specific piece of it because that's our insertion point. But insertion point only grows with a broader solution becoming successful. So it's really important that there's the right balance of investment into what the center is going to focus in on to bring the whole system view forward. I think John was mentioning, it's how do you take all this, either in situ monitoring, remote sensing, and boil it all down into something that's meaningful.
So I think that's a really good point, and it's something that such a center like this exactly is going to enable, because the industry advisory board, which is formed by members of industry, members of the center, essentially sets the research agenda for the center. It's not faculty who come and set the research agenda. The industry folks say, this year we're going to focus on these 4 areas. We're going to issue a call for proposals, and we're going to collaborate with faculty in these schools on, these projects which fall in these buckets. And then maybe next year, the industry advisory board decides on other topics, or there are additional companies that come into the game, and collaboratively you guys decide again what is going to be the research agenda of the center.
Yes. Speaking of which, you will be participating in a kind of a mock voting session tomorrow. That so based on what you heard, for example, yesterday, I believe the program is to have all the industry partners, potential partners, to speak up about what they liked, what they didn't like, and you would be voting on what projects or combination of projects to select if we were to, if this were a real scenario and funded center, that you would be telling us which projects we'll be working on. And Max, did you want to say a little more about that? And by the way, that session would be without us as the university research in there. So it's basically among all the industry partners that this discussion will take place. Yeah, Max, please.
I think you described it pretty well, Mata. I think, one of the great things about, kind of how this is all set up is that tomorrow will be an opportunity to reflect and discuss. Right. And what you'll see is that there'll be a time for the center leadership to provide some feedback to the comments that were provided in the life system, and to begin the conversation of evolving the research topics, or kind of like the application of the research elements to align with the IAB needs, right? And kind of beginning that conversation and maturing that relationship a little bit. That will evolve into a conversation that I'm actually going to moderate, which is going to be your feedback, right? So taking in a lot of what has been even said today. I've been taking some notes to kind of generate some good conversations and more questions for tomorrow. But basically just finding that alignment, right? Finding those sweet spots of what do you wish you could do today that you can't accomplish because the technologies don't exist to be able to support that, right? What are those elements? What can we really do to kind of create that, find that overlap and try, it's almost like a Venn diagram in real time, like build that Venn diagram and help Mata and her team expose those different elements. And then that will roll into the mock voting, and it is, it's not binding, but it is an opportunity to see kind of, where the different organizations would place their not their bets, so to speak, but basically their votes for what you would prioritize on the research projects as they are stated currently, or maybe, even slightly modified in terms of, kind of what the different outcomes you're looking for are. But it is it's all intended to generate conversation and to lead us in the right direction for the future.
Thanks, Max.
I'll mention one more thing again, by way of a pitch for the center. So Max's role, in fact, is very unique in this center as well. Unlike other centers that NSF funds, or definitely unlike research projects that NSF funds. So IUCRCs have an independent evaluator or assessment coordinator. And Max's role is really to provide NSF with an external independent assessment of center activities, collect center required data, and we have to provide this data to him in a timely fashion. And the bottom line is that Max is essentially an interface between industry and academia in this center. And with the assessments that he does, he makes sure that industry members are getting their money's worth. That they are happy with the conduct of research in the center. That if there are any issues, it will be brought up to him, and he will then attempt to, with the academic leads, to address those issues. So it's a very important role. Again, it's unlike other centers that NSF funds, which are not industry funded, but here really industry is not just in a driver's seat in the advisory board. But NSF dedicates, one person to make sure that industry is happy with what is happening in the center, because they want memberships to continue and they want memberships to flourish.
Great Payman, right on point. Thank you. I know we only have 2 minutes left this meeting. There's one comment about data standardization. Maybe a quick comment about that. Deb brought this up, and I know that John and Mike have commented on that as well, and our colleague from T might want to pay as well. But if you wanted to just say a little bit about that, that would be great.
Yeah, I think particularly in the water area, it's a big need for data standardization, and it's an evolving field because we have so many different sensors, from coming from universities and private players. So all these different sensors, they have different accuracy. So standardization of that, some sort of from university, so backed up by literature, I think that will be greatly benefit the community. USGS has done some as far water data is concerned. So I think similar approaches could be made for soil data. At the same time, I think it's important to do or have some framework to manage metadata, because as we progress in the future, as we have more sensors, we'll have more data. Their accuracy would be different. So how do I compare a data I collect today to a data that I collect 10 years from now? So unless I have that metadata information, I cannot compare those two data sets. So it's important to log those metadata. Who is collecting, how it is collecting, how, all that information.
Yeah, and I think that goes quite well with the idea of eventually deploying any solution at a large scale and at a commercialized scale. I think that definitely has to take place. That's an excellent point. So I would hate to keep everybody over time, and everyone's busy with other meetings. And if you're on the East Coast, ready for the end of the day, really appreciate all the wonderful comments and inputs. Looking forward to seeing you all tomorrow, 9:30 a.m. Pacific time.
I think we're happy to stick around if you have
Absolutely.
questions. I have time,
Yes. Me too.
so we'll
I
stick
can
around.
stay on, but don't feel like you have to.
Yeah.
As you like.
Exactly.
Yeah. Please.
Thank you.
Would you like to share any final comments? Max, thank you.
Thank
See you
you
tomorrow.
all.
Thank you all.
Thanks, everyone.
Thanks, Mike. Bye.
Thank you for coming.
The
Yeah,
tea was good.
Yeah, go ahead. Sorry.
The tea was good.
Oh, it's great. Glad to hear that.
Glad you liked it. Did you try tea cubes? I heard there were things you drop in hot water and it becomes tea.
Yeah, they were good until you get to the bottom of the cup.
That's right. That's right. I was just telling Matt, it's like astronaut tea, so very compact and
hopefully tastes good. Yeah. So, on the topic of hopefully an attractive feature of the center being the collection of ideas, or just combining the different solutions and with this integrated vision, I think we would all be really interested in exploring that further and understanding how, from the industry perspective, what how we make it feasible, accessible, along the other comments that you've made, that the end user doesn't want to deal with all the data. If we have in situ, we have satellite, we have geospatial, all these things. What should be? How can we single step through this process? And of course, it goes to the advisory board deciding on the projects and guiding the university researchers into what you think are those single step processes that we need to follow. That's something maybe we can think about and talk more tomorrow.
Does this center have an obligation to come up with a commercialization plan? Because that's, first you have to develop the technology, but is there a deployment plan aspect to these projects?
I don't think there is any requirement for that. except that because it's industry driven, we will be waiting for your guidance on that. You need to commercialization on your part, and then translating that into research for us.
I think that the research is meant to be so-called pre-competitive, so that it can be shared. And typically what happens in these centers is that a project is funded. Let's say that Jim decides that he's interested in working with Mata on a project, and write a proposal, submit it to the center, it gets evaluated. And typically the projects are on the small side, maybe just 50 to 75, maybe 100K, which means that one student can be supported for a year, a little bit more maybe. And that results in some interesting research results. And then Jim's company decides, this is great. We would like to now further develop this. We have a license to it because it has resulted in some sort of pre-competitive, maybe IP. We'd like to take this in-house because we think that there's more potential to it. And the companies can do that, and they can do that either with the faculty member or without, but basically they would exit that, they would take that new research result and take it with them to the company for further development. But commercialization is not, I think, a metric for the center itself.
In practice, David, what we've seen, right, is because we're participating in a water one up in it actually originated back in the University of Milwaukee, Wisconsin. And there's been a whole ecosystem center created around it. So and we were not an original founding company, but we participated sort of later in its phase. I think it was on phase 2 plus it was the second funding of the phase 2. And they actually created a whole startup ecosystem out of it. So funding companies might take the technology, but also they actually may spin out startups that ended up getting affiliated with this center, WEEC. I can't remember what it's Water, Environmental, Economic Studies or something like that. But that is, I think that's been an IUCRC that was around for, I think, 10 to 12 years. But where it ended up, it's, the small idea incubated and grew to, actually, I think there were 15 startups and a couple of other bigger companies involved. So we would do this for the long haul, right? I mean, this is
exactly. I mean, this is
going to happen in a year or two.
Yeah.
But 5 would be, I think, from our perspective, would be a nice minimum horizon.
Yeah, I agree. I think that's for the long haul. Yeah.
Yeah. Great. Okay.
So
well,
go ahead,
Payman. Yes, please.
One request to non-center folks here, Jim, David. I think that's essentially, we would really appreciate if you could sort of introduce the center idea to connections that you have at other companies, because we have deadlines coming up and we really have to meet that minimum membership that NSF requires from us. If we hit that, then essentially, the center is spun up and the stress level goes down a little bit and we can work on some of these really cool projects. And on the side, work on recruiting more members. So this, Jim, you know this because you mentioned phase 2, you know how these centers are run. BizDev is a constant running theme. You have to be talking to companies, you have to be signing them up. There is some attrition at any given time. And so if you can, if you can reach out to your connections in big and small companies, ag, remote sensing, in situ, food, carbon capture, whatever, we would really, really appreciate it.
Yeah, actually here I would like to say thank you, Jim, because back in 3 or 4 years ago when we met, and so the Jim already being strong, the supporter for our research at UConn, and actually you and I, we visited on-site 2 years ago, right? And then we had a lot of communication since then. And so the Jim, just like Payman said, that's the, that's the first we thank for support, and actually another way that if you can spread word about this Signal in the Soil, the IUCRC Center, So yeah, for more and more industry should membership.
Thank you for the kind words by Kuhn. And I mean, I think what you guys are doing here collectively is really important. I mean, at the macro level. And, you know, as a commercial industry, we always have profit and you know, loss requirements and all that type of stuff. But one thing that's been nice about Onset anyway is we try to tie ourselves to things that actually do matter. And I really do think this matters. And I'm happy to extend the exposure. I'm not sure that I have a lot of direct contacts, but I'm happy to use whatever Rolodex I might have. So thank you.
And I know of some ag sensor companies, but I don't have any direct contacts. Would it be okay if I sent you a list of company names to follow up with?
Sure, absolutely. Yeah.
That'll be long. Yeah.
That'd be wonderful. Yes, thank you. Okay.
Okay, I think we should probably close this
Yes,
up
we should,
and
everyone have some time. Yes, thank you so much
you,
again.
David
Great
and
seeing everybody.
Jim. And if I can ask the team members to stay on for just a few minutes, I'm gonna pause or stop our recording and
Sure. Okay, yeah.
So Jim and I discovered that
Thank
we
you,
grew up 10 miles apart.
That's amazing.